think of AI as not just an individual efficiency amplifier, but as an augmenter of your organization's intelligence. Think not just in terms of accelerating individual outputs, but enhancing organizational outcomes. AI generates code faster. It does that too, but that's not where it ends. Knowledge belongs to the organization, and everybody is contributing to the organizational context and drawing from the organizational context.
Sashank Purighalla is the founder and CEO of BOS Framework, and this conversation sits one layer above the usual AI coding discussion. A lot of people are focused on the dark factory question, how to generate correct code automatically. But Sashank is asking how to get infrastructure and software right at a larger scale, with cloud infrastructure, deployment, compliance, and the software development lifecycle working as one integrated system. That means thinking in terms of durable infrastructure patterns, approved software patterns, organizational knowledge, and team workflows, not just whether an agent can produce a good feature or a clean code diff. He brings this down to earth with examples of patterns and guardrails that teams need if they want AI-generated software to hold up in production. The core idea is that you can automate a lot of code generation, but you still need a business operating system that helps teams understand the right high-level software and infrastructure patterns and how to operate them dependably. Let's dig in.
The problem that I see is excessive focus on tooling and coding versus what AI can truly accomplish and achieve for companies and for individuals, which is outcomes. So I think we are confusing in many ways, John, the difference between accelerated outputs, where we should really be focused on exceptional outcomes. And I think the approach and the thought process, the mindset in both these cases is slightly different. So I think where I think we should elevate the conversation of AI as a race is, okay, how does this augment our ability to achieve greater outcomes for humanity and for organizations rather than accelerate specific outputs and get that dopamine kick. Excessive focus on part compromises the integrity of the whole. And I've seen that happen and play out very, very much so in the world of AI, where we're focused on producing exceptional code or excited about one document that it produces, but how do I transfer it to another person? Because when I work with that other person is when we are together producing that outcome.
It's like a case of you can't see the forest for the trees. That's like everyone is focused on, I can build a better tree, and
Right.
There's a big, broader picture.
Right. And I've actually seen this play out multiple times where when we started having individuals work on it, and I started doing this myself, I built this huge, long thing, and I'm excited. I'm amazed in many ways with what was produced. But now I have the responsibility of transferring all that over to somebody else. That requires that person to now read it, consume all that information, whether that's code, whether that's a document. Even at the level of one document, let's say that's 30 pages long, it becomes humanly difficult to consume that document, absorb all the details, and do something. So now think about what happens in a team of 5, 10, 15 people. So even before we get to an organization, let's just take a small software team that has, let's say, 2 programmers and 1, let's say, business analyst. This problem exists.
Maybe this would be a good chance, since we've kind of laid out the problem space for our conversation today. Let's back up. I gave you a little intro in the introduction to the video, but tell us a little bit about yourself. What's your background? What is your company?
Yeah, so my company is BOS Framework, BOS Framework. I called it BOS because it's the business operating system. Like I said, I'm a software engineer, and I always think of technology as a business tool. So for many years now that BOS has existed, I always called it the business operating system to see how we can bring technology to provide those business outcomes. So I'm the founder and CEO. My background, John, is in software engineering, cloud architecture, product development, enterprise modernization, software delivery, leadership. in all of those areas. I've been doing this for about 25 years now. And what I observe is that most software problems are not technology failures. They are a result of poor process, governance, architecture, execution at a team level. So BOS is really to bring that structure, and my interest in AI is also along the same lines.
From my own perspective, I've been traveling down this road of automating my tasks more and more. And initially, I was a developer with Copilot, so it was like autocomplete, was like great. I didn't have to think for a sense. Then we came up with these coding agents, and you could have it like complete entire files and stuff. The agents have gotten really spectacular. They're coding multiple file changes, and they're actually doing a pretty good job of it at this point. And I feel like this is a really important moment in time where that's starting to escape beyond the contribution of me. So I'm really curious how this translates to supporting entire organization. Are we talking about things, the dark factory? I know when you talk about the business operating system, it feels like automating certain aspects of the business. And how do you keep all this stuff in check? Like there's institutional knowledge that's built in people's heads and poor documentation. How do you tackle this problem of taking what we learned for individuals and bringing it to organizations?
This probably is the single biggest question that we're trying to answer as an industry, if you think about it, because ultimately development, innovation, software development specifically is a team sport. Even when one person uses it, what the person probably subconsciously is doing is playing multiple roles, either sequentially or in tandem within his own head, right? There's a visionary, there's a business person that says, here's the business outcome I want to accomplish. So he's acting as a stakeholder. There's a business analyst or a product manager that's defining the product and saying, this is the functional specifications that I'd like to hit. And then there's the architect that comes in and says, here are the specific architectural patterns, the standards, the tech stack I'd like to use. And then there's a developer, and then there's a tester, and then there's somebody that's doing the cloud and DevOps work, and then there's the end user. So there's all of these people. So whether it's one person or multiple people, there are all of these roles. When an individual plays all of these roles, what the person is doing subconsciously again, and maybe just intuitively with the AI tool that is in play, is ensuring that that context and the continuity between one node and the other node is maintained and preserved. Because in one person's head, it's easy to maintain that continuity, that context. When you take it beyond one person, and many systems are larger than what one person can manage, this is where you need it. You need specialists. So how do you take that beyond one person into a larger, and you said this yourself, that dichotomy of institutional knowledge existing in individual heads, right?
Yes.
And now the organization becomes beholden to individuals, and every single person becomes a potential fault line. How do you deal with that problem? So is there a way, the question that becomes obvious now is there a way to take all of this context that would exist in one person's mind and somehow create an organizational mind where this context can be ported over to? And if AI is leveraged in the right manner, and we'll break out what AI really means in this context, but let's say AI is somehow elevated. If that context can be taken to the organization's mind, then AI really works very well, because now instead of AI becoming an individual tool that somebody is passing over to somebody else, AI becomes the organizational augmented intelligence which people are partaking in and contributing to. So AI does make this possible because you have the ability to transfer all of that information into vector databases, into RAG systems, and hold that context separately.
Very interesting. Yeah. As an engineer, I've always had this problem where it's like, what is the product specification? This is not a new problem. It's just we have interesting new tool to work with it. I have always had the problem of like, okay, what is the product specification? oftentimes it comes from a conversation, even before it's like documents. Sometimes it's just a conversation like the product manager. I think this is a good idea. And then it goes into the engineer's brain and I heard wrong, and it comes out whatever. And like documentation at organizations is notoriously out of date. It's like well-crafted lies. That's what I've heard of, like the documentation. But we are using these tools now in a way that maybe we could fix all those problems. Like already on an individual basis, when I'm developing an application, depending on what type of workflow I'm in, sometimes I engage in spec-driven development. So I build a product spec rather than just show, like make a screen, I actually think really deeply about what to do. And then that makes the AI do a lot better job at moving toward the thing that I had in my mind. Now, I think what you're getting at, again, is the same pattern of we're taking the individual specification and we're pulling it out to like the company-wide basis. So what types of specification are we talking about? I got so many questions here. What are the specifications you have in mind? Is it just software, or is it like everything, HR even? How is it maintained? How is it modified? How do you keep people from corrupting it? Like all the documentation for my career.
You must have a system to ultimately manage all of this. Coding has solved this problem a long time back with version control. All our Git repositories have a fantastic way for people to maintain the versions of their code and then compare two versions, sometimes revert to a previous version, previous state, check in, check out. That way one person is working, you're not stepping on each other's toes. And when you check it, somebody else can check it out and then start working on it and update. Then you have the ability to merge changes. If we took that exact paradigm and brought it into organizational documentation, for a moment, let's just stick with software. And let's just play a real scenario, right? If you're building an application together with a customer as an individual consultant, you're not coming up with all the requirements yourself because you depend on the customer. And the customer invariably gets inspired or maybe informed by the discussion he or she has with you, because you're probably contributing to that thought process. So now both of you are collating, and there is a common document. If you just maintained a Google Doc, you'd both be contributing and then you would know exactly what's happening. How would this work with, let's say, Claude, if you were to do this? You work document, it's on your computer or maybe in your specific account with your login. You then download it and then pass it over Slack to somebody else. And then that person uses that as part of that person's context, however. So it becomes a little difficult to collaborate. How about having a system in this scenario where if you looked at a team engaging with that exact use case and you had multiple people working on a specific document, whether they're working synchronously or asynchronously, the document gets updated, and throughout there's human inspection to look at the document and say, is that drifting from the intent? Because that happens with AI. Or is it in line, and have the dexterity to either make changes manually or have AI, prompt AI to make those changes. And have that, again, peer review. I write something and then I have John review what I have done, and then we say, okay, that's the document. But version it at every point, because even if there's a little drift, we say, oh no, the previous version was right. And then go back to that previous version, either update the entire document or a section of the document. So I think this is the system that we need, a system which keeps up with multiple people. So an entire team working on it with a workflow of who is going to be working on it, when, at what point. Obviously, everybody's not working on everything. So there is some responsibility, assignment, allocations. There is a knowledge base that everybody now starts consuming from, and that becomes the organizational knowledge, if you will.
Well, so it's as if the software for the company is becoming like English text. It's just an abstraction level higher, right?
And really, it's the ability to define what we're trying to build and describe the end state of that system. In English, yeah, but really, if you're just think about pure engineering, right? If I were to empower every single builder, every single construction worker with a magical tool that 10x's their performance, it's not about everybody swinging that hammer faster and getting more number of hits. It's about ensuring alignment with the blueprint. So everybody is able to ensure that whatever they're building is always in line with that blueprint. So the importance here is of the blueprint. It's of that upfront thinking, and that's what happens in pure engineering. Software has had for the longest time the luxury of postponing those decisions, and we called it agile, but it was really delayed decision making, and we'll figure it out along the way. And so costs could go beyond our control, but that was accepted. Today, you don't have that luxury anymore. In fact, AI is acting as a forcing function that is forcing everybody to define it up front and make those decisions a little early in the game. And this is something that I've been speaking a lot to several people about, John. AI is organically, it is pushing for greater structure and greater engineering discipline into software, which has traditionally been missing. Because start with the blueprint in engineering, we did not have to start with the blueprint in software. We just had a conversation and we just get started with code. How do you do that today without really defining what you want? Because AI can produce a lot of code and it could be a lot of trash.
Very interesting. Historically, like the people have been up at the very top and run the business. The idea of waterfall is at least appealing. Like, I want to say what the plan is and then just watch it come into place. And historically, that's worked really well with bridges because you have to have something up in place. But it's been challenging with software because things kind of move, and it can move. But now, since coding is no longer the bottleneck, we have all this new tool, AI, that we can speak to and it speaks back to us. We're finding that maybe it's easier to actually create the big picture first. It's not that it's not subject to change. I mean, things are actually more flexible in that direction too. But we have the opportunity for, like, here is going to be the big picture. And sometimes it's like you push a button and like the feature comes into existence immediately. It's amazing. Well,
Yeah.
So when you are working with different systems, there's knowledge that people said about what product is being built for existing products. There's knowledge that people said about architecture, like two different things, but they're both very important. Product knowledge, architecture knowledge. At the end of the day, how do we test it and deploy it? So it's kind of the two things that are on the outside of the coding. As you are integrating this business operating system into a business, how does the adoption work? Is it a gradual thing? And how does it work for new projects versus like existing projects?
I think anybody that's been using AI for software development for a few months, let's say 6 months, has probably encountered that point where how do I get the entire team to work in a consistent manner? And it's an active problem that they are experiencing. And there are specific reasons why they're experiencing that problem. And we have called out 3 specific reasons why those problems generally surface. AI tools natively don't support team engagement with multiple team members playing specific roles and all of them being able to collaborate with one another. And so while they're working as individuals, how do I pass that data becomes problematic. Second one is, now when we talk about these teams working and producing outputs, whether that's a requirements document, an architecture document, technical specifications, code, test cases, as the case may apply, all of these are really not individuals do not own those outputs. The organization owns those outputs. So thinking of context not as individual context, but as organizational context. And the third one is there has to be a well-defined workflow. It has to be sequenced. Who works when? Even in a collaborative environment where everybody talks to one another, not everybody is working on everything at the same time. There is a sequentialization, there is a parallelization of work responsibilities. So these are the 3 problems, the 3 pillars, if you will. Team, knowledge, organizational knowledge, workflow. which become really important to introducing what would be, people call it a factory, people call it, we call it an operating system. These are the pillars of the system that ultimately enable these problems to be solved. The question becomes, how do you introduce that system? How do you build that system? So what we've done is we've built a system that natively provides these capabilities. And I've seen many other organizations, other leaders that I speak to, come up with real world methodologies and processes which are essentially solving for these three elements. The bottom line is, how do you follow that discipline? How do you follow that structure so that outputs can be achieved? So I think individuals will have to firstly rethink their involvement with AI and with the rest of the team and that engagement. So there's a little bit of reorientation, reimagination, and then redefinition of how they work. For an organization to achieve this, that culture, I think there has to be a little shift, and that always starts up top. And this is not some powerful leader coming and saying, this is how we shall do it going forward. It is a coming together of minds at various levels saying, what we've been doing requires a slight reimagination and doing it slightly differently. And this redoing it is because we have an augmented ability to work at a different level of speed and efficiency. And to make it effective, we've got to bring in the structure. And that structure is only possible when all of us work together. So right from the highest levels to the lowest levels, I think there's a little bit of readjustment, recalibration of how they start to work.
And is that just to get like the software developers so that they are paying attention to the global organizational spec? Is that to make sure that they're following their own, the correct processes? What is that change that an individual takes, even the different role of the individuals at the company?
I think everybody has to first slow down so they can speed up. In the past, I would have developers, and I'm sure all of us have seen developers just jump and say, I'm going to start writing code the moment you start talking to me. And then they try to produce something. I'll say this as well, John. Software development is not just developers. It is all the events that go into software development, into the life cycle. So it's the visionary, it's the business leader, who's the stakeholder. It's the product manager or the business analyst. It's the architect. It's the tech leader. So software developers show farther down in that food chain, if you will. So everybody has a role to play, and if they don't define what has to be done clearly up front or validate whatever somebody writes up front and say, yeah, that's exactly what has to be done, you will see downstream impacts. And because of the speed of execution, the downstream impact is going to be amplified as well, whether it's positive or negative. So if lead measures taken, again, that shift left, if you shift left and you do it right, define it right the first time. So if the business stakeholder says, this is exactly why we want it, and here are the business considerations, the product manager is more likely to write the right requirements, which then probably makes modeling the architecture and the technical specifications better, and so on. So it's not just, the onus is not just on the developers. And developers, of course, will have to understand that now their job function has changed from being coders to problem solvers. So there's more planning, there's more problem solving, and there's more validation of code because that execution part is being handled by AI. They don't have to write as much code, but they have to, accountability exists with them though, right? You cannot delegate accountability to AI. It's still with humans.
Maybe since we're kind of on the subject, and if we'd like, we can get back to adoption here in a second too, because I am curious, like a concrete scenario for adoption. But we're on the topic of roles, and roles are changing quite a bit right now. Last year, everyone was like, well, is AI going to take my job? And I think the fortunate consensus is coming that no, AI is going to change your job considerably, but there's going to be a lot of new roles that exist, even if some of the individual skill sets are kind of going away. So as far as the old players in the game, product manager, project manager, kind of holding everything together, architects, engineers, people manager, and even like CEO, CPO level type stuff, how are they going to engage with the new world? How do they need to change? And what does the new shape look like? Who should we be hiring?
I mean, I think everybody likes fancy titles and changing those titles around, but I don't think they really need to be changed. My personal opinion is product managers stay, like you said, project managers stay. I think you really don't need coders as much. You have to think about it as software engineers. And I don't think software engineers are going anywhere. In fact, they're more relevant than they've ever been because problem solving is not going anywhere, right? And software engineers, I think the one big positive for software engineers that AI has done, although there was that little bit of jittery, everybody was a little nervous about what happens to my job kind of a period, where everybody is now landing comfortably at this point where there are two different aspects.
In our conversation so far, we've outlined a really good why. Like, we need an operating system. We now have the tools so our specifications don't stay in people's heads and leave when people leave the company. And we have tools that will help the entire system as a whole into the direction we want. Very strong why. What the viewer of this are keen to learn is like concretely, like what does that look like for their company? They have an existing code base. They have new things, directions that they would like to go. They have really old documentation that someone, a few people try to religiously keep up to date in Google Docs. And they have tickets over here in Jira. Like, how does that get morphed into the operating system for the business?
To solve that specific problem, to provide organizations with the ability to introduce a meaningful mechanism to engage everybody with AI and produce outcomes, we built what internally is called the Forge, but we call this the operating system for software delivery. It's built on three pillars: organizational knowledge, team collaboration, and workflows. And we have three layers that we think of as we do this. The first layer is understanding that the knowledge belongs to the organization and everybody is contributing to the organizational context and drawing from the organizational context. So the operating system for software delivery has a capability where it accepts the knowledge base as the input and retains that as the core knowledge based on which everything in the organization is done. I'm speaking specifically in terms of software. What does it include? It includes the standards, the acceptable architectural principles, the policies. Policies not just whether it's a SOC 2, GDPR, or HIPAA compliant company, but also the types of technologies that are accepted and not accepted, the specific libraries that could be used and not used, the infrastructure architecture that is, or the reference architecture for AWS or Azure that's accepted. All of these would become the organizational knowledge, and people simply say, I want to use this particular reference architecture, or the AI has the ability to suggest this is a meaningful architecture that's approved by the organization. So that's the organizational knowledge. The second layer, which most people call today the software factory, we look at that as one of the layers, which is AI-driven SDLC. When we say SDLC, software development lifecycle, AI-driven, again, every role that has a contribution to make for that outcome has a presence, and one or more people are able to play that particular role. So this is where the entire team comes into picture, right? So that's the second layer, which is the AI-driven SDLC. And the third layer is a runtime factory, which many people are not necessarily talking about, which is how your infrastructure works. If you are able to produce AI at warp speed, are you able to deploy it and sustain it and operate it? Because I can vibe code, but I cannot vibe production operate an enterprise class environment. I've got to be careful and intentional about it.
This is something I've been thinking about. Is like, I realized, I came to this realization recently, like, wow, I've got a superpower. I can make any product SaaS is doomed because like I can vibe codes any SaaS I want. But then I'm like, well, now I got to deploy a giant database potentially, and I got to maintain it, and something's on fire, and I've got to figure out where the problem is. And that's a key point that the vibe coders of the world, we don't have the answer to that clearly yet. Maybe this is the answer that you're bringing to bear. Teach us.
I hope so, because this we feel is the biggest problem that people. We are so focused on individual amplification, individual efficiency amplification or acceleration, and we're so focused on code production. We're almost missing the core reason that we exist as software engineers. Organizational outcomes. How can you achieve an organizational outcome without deploying it to production and sustaining it over the long haul? So you've got to have the same level of efficiency, the same level of discipline rigor that goes into code production that on the infrastructure side. In fact, probably more, because organizations can live without having a certain feature, but they cannot live without having reliable cloud infrastructure, because if it doesn't work, it could be catastrophic. You could lose your entire business, one breach, and you could be in the headlines for all the wrong reasons.
Right.
So those three layers, John, knowledge, the what everybody calls software factory, which is really AI-driven SDLC, and runtime factory, which is your cloud infrastructure, intelligent automation, right? DevOps and cloud automation. Those three collectively is what we say is an operating system, and that operating system is able to bring in multiple team members together with their roles clearly specified, two with workflows, and three with the organizational knowledge base always held with the right, version control and management, so that you're not overwriting somebody else's work or using the wrong version of the document, or you're drifting and nobody knows when the drift took place. You have that traceability. So for this, we built a platform, and that platform has those two aspects: something to handle, do governed SDLC, and to do governed cloud infrastructure and automation, and to always hold that both for new projects as well as ongoing, modernizing existing products.
If I may, why don't you just let me know if I'm getting too close to the secret sauce or anything? But people are dying to know how this is being attempted, how it's being done, what works, what doesn't work. When a company approaches you and say, we realize the potential here, there's an opportunity, how do you help them get their house into order? Is it collecting all this documentation and putting it a RAG application, or is there something bigger, like take the magic away?
There's an interface that we put in front of them. It's no different from Claude, except it's a little bit more geared toward a team using it. So we help them get onto that. And what we have done, John, is, collective experience gathered over decades of collective experience between our team members. We brought in many from the cloud architecture side, reference architectures for AWS and Azure.
Okay, sure.
That are pre-built with SOC 2 readiness, HIPAA readiness, evidence collection, observability, maintainability, cost management considerations, security, alerting, monitoring, etc. So there is a very easy to use, no code, intelligent capability for cloud automation that we provide to our customers.
So if I'm jumping into a new product to be the expert of all these fields, because I don't know anything about SOC 2 compliance, but you have reference architecture that acts kind of like a cookie cutter, not like the cookie cutters of yesteryear where it's exactly this, but it's a very flexible version of here are the best practices, here's how to structure your cloud deployments so that you safe data governance, that you got accountability, and all the things that big organizations obviously need.
Correct. It's also not a straitjacket in the sense that what does every development team need to put their product out into the cloud? They need some compute, right? They need a database, and that database could be Postgres, it could be SQL Server, it could be MongoDB, it could be, Cosmos DB, it could be anything. They need a storage like an S3 bucket, right? And It's not just the compute data and storage, it also has a lot of networking constructs that go into building an environment. There are a lot of security elements that go into building an environment. There are dependencies. So when we say a reference architecture, all of these things are pre-built and made available to somebody in a manner where they can select what database they want. They can select what compute they want. The inner mechanics of how all of that configuration is done to bring about a secure environment is automatically handled by the operating system, if you will.
That makes sense.
So what people use technologies like Terraform. You need AWS or Azure certified solutions architects to be able to build these infrastructures, and you need senior cloud engineers. In lieu of all of that, this capability allows dev teams to be able to produce their own, provision their own infrastructure, and maintain it. So when we go to a company, it's not uncommon for us to see, and this is generally the landscape. They have somehow built cloud and they have somehow made things to work, and they're struggling with how to maintain it. They're spending a certain amount of money on it. And when you talk of cloud costs, it's not just cloud cost like what you spend on AWS, it's also the people cost. It's also the other software that goes into it. So the total cost of ownership. It's a fairly expensive deal. So we help them move away from that old infrastructure by setting up new infrastructure that is in line with their application's needs. Will lift, transform, and shift kind of a migration, and then now that becomes their reality. The number of engineers they need for maintaining that cloud infrastructure comes down dramatically, and they don't have to go and retrofit SOC 2 compliance into this by collecting those evidences because it's built ground up on those foundations and those evidences are already in place. Many companies try to inject niche tools into vulnerabilities and say, I'm going to achieve resilience somehow. It's not going to happen that way. So that's on the cloud side. On the application SDLC side, up until the point of, so everything I mentioned about the cloud is once code is produced, how do you pick it up and then deploy it to the cloud, right? On the code production side, which is where many people are focused, we go in with pre-built policies, pre-built good practices. We make that available to our customers, right? Visualize a company that doesn't have many good practices. They could just say from 0 to a certain level of high maturity, they can get there in a span of a day or 1 week because they get immediate access to that thanks to what we've done. Then they prompt just like they do in Claude. But because of these policies, we are able to, through Forge, enforce guardrails and ensure they never produce a single line of code or a single document that goes past those policies that have been put in place.
So what kind of policies do you have in mind here?
Let's take something very simple like I need two-factor authentication. If I need two-factor authentication, how would you do it in the real world? How would you do it with Claude or Cursor?
I would ask them to teach me how to do it, and then I would kind of follow what they do. But I suspect there's a lot of different ways to do it, and there's probably narrow set of ways that are the best ways to do it.
And there's also architectural integrity because you've got to do it in a certain way that then works consistently when you have a distributed distribution across multiple, cloud accounts across multiple regions. So there are multiple things that play into how you do something like this, right?
Oh, so this kind of like the reference architecture, but this is like reference coding patterns for certain aspects. Obviously not the core product,
but designed for scale, designed for deployment. So we're not just looking at functionality, we're looking at ongoing sustainability and operation as well. So when you look at a policy like that, the policy is not just, hey, I need two-factor authentication. If you went to Replit and say, I need two-factor authentication, it's going to produce two-factor authentication for you. There is no telling what it has actually produced. And you could test it all day long. It's going to give you fantastic results every single time until it doesn't work in production at the most inopportune moment. Why? Because things go wrong after a certain scale, right? So that's an example of a policy. Another policy is just, if you just said SOC 2, SOC 2 is a guideline, and you have multiple ways of interpreting that, and somebody has to do that interpretation for you. So when you write a policy, you have to define the controls, and those controls have to be interpreted and implemented in technology in a certain way. And that implementation is not just on the application side, it's also on the infrastructure side. And the application and infrastructure have to coalesce and they have to work together. So when you speak about a policy such as this, you're talking of the coming together of multiple elements into a single whole. And in the real world, if there were no singular centralized location where all these factors have been considered, multiple people will have to keep in mind that this has to be done. So the product manager has to write this requirement. The developer and the architect have to think about all of this, and the infrastructure guy has to think about how to implement it, and they all have to collaborate and work together under a project manager. It's a difficult process. Visualize this becoming available immediately because the system inherently natively manages this, right? If AI does it right, this is to be expected, right? I mean, this is the expected behavior of AI, that I just tell it and it does it. Only it doesn't, because AI does not know to ask all of these questions, and you need the architect to come in and ask. But why ask every single time, where it could become institutional knowledge and say, this institution has been built on SOC 2 and is SOC 2 ready always. Every project that's built or modernized is going to guaranteed follow this. It's definitely going to follow this.
I see the benefit of that. So, like, I can vibe code and say I need SOC 2 compliance because someone told me, and I'm not a SOC 2 expert. It'll make something and it's going to say, I'm done. And I'll be like, well, I guess we're done. I like the idea of references, reference architecture, reference software patterns. If you have something that this is known to be like rock solid, this, if you follow this pattern, it won't lead you astray. Then starting from that cookie cutter reference is a good way of making sure that the AI does not stray too far off course. And when it's time to revisit decisions, well, you know what the decision was because you can go back to, here's the reference that we used.
There's traceability, and then you know when some decision was taken by whom. And if something changes, you're looking at holistically. You're not just looking at it and saying, oh, now I understand something changed, change it for me, AI, and hope for the best is not. In fact, today we have more reason to be accountable to what's being output by the AI systems than we had in the past. Because in the past, there was a slowness to life. And we could go and we could afford to make changes and say, I need 6 months to make this change and I need to hire some external vendor. Today, people don't have that patience. And if you have a vulnerability, people can go and hack that system exceptionally fast. So you have the responsibility of always being prepared. And that accountability you cannot delegate away from your desk.
So I think we've made it through 2 layers of the operating system. The knowledge layer and the AI software development lifecycle layer. Now we've got one that's kind of foreign to me is how do we turn this into deployment DevOps type stuff? Is that going to be a similar flavor, or tell me about that layer?
So we debated long and hard internally as to whether we just use AI for vibing and just generating code every single time for the cloud, or whether we make it a little bit more persistent, a little bit more immutable. And I've seen a lot of discussion about immutability of software, or mutability of software, and trying to bring the same thing into mutable infrastructures. I think there's a little confusion here. Containers, and I'm addressing the technical audience as I say this, and please tell me if I need to dumb this down.
My audience is very intelligent.
Containers are, by definition, ephemeral, which means they are highly mutable. But there is an architectural orchestration with whatever orchestrator we're using, like Kubernetes, to ensure that that ephemerality is handled in a meaningful manner. Kubernetes itself cannot be mutable. It has to be immutable, right? So that's that dichotomy that has to be understood, and they have to coexist. There is a part of it that is mutable, but by design and by architecture, but there is a part of it that cannot be mutable, that has to be immutable, that has to persist. So we call the infrastructure layer intelligent automation rather than just AI-driven infrastructure. And what we mean by that is there is an infrastructure architecture. There are reference architectures for AWS and Azure. They're built with well-architected foundations. They're built with CIS compliance right from the get go. It's built with all the necessary constructs for alerting and monitoring, observability, traceability, logging, security. And those foundations do not change except when we go and make changes, and there is a very well versioned update whenever that change is made. And that's pushed to the universe of everybody that's using this particular operating system. We have been prescribing that for everybody we work with and that I speak to, because you cannot have AI produced very quickly with the cloud infrastructure not being as solid. Like I was saying earlier, you can wipe code, but you cannot wipe operate production systems. You have to operate them with intentionality, with certainty. So to bring that deterministic aspect, we have built it in that manner. Because code is being produced by AI, it is all the more important to make sure that it is scanned thoroughly. So we have to make sure that the DevOps pipelines are done with multi-stage intentionality and design. Code scanning, right? SAST, containerization, container scanning, all of those steps that you have, as well as looking at code completion, code coverage, dependency scanning. All of these steps are baked into our CI/CD pipelines. So the third layer of this, which is the runtime factory, which I have been calling it that, is the coming together of the infrastructure automation, both while provisioning it as well as ongoing operations, and the CI/CD portion of it, which is the DevOps, which is this multi-stage, multi-job pipelines for continuous integration, continuous deployment with built-in scanning for security, code completion, code quality, as well as container security, etc. And this requires ongoing maintenance. We scan every single environment that is put in, that's provisioned every 2 weeks for vulnerabilities. So we have vulnerability scans of the infrastructure, vulnerability scanning of the application, threat detection, security and compliance scores generated every 2 weeks. And there's continuous remediations being put in place, because especially with AI, there is just so many CVEs, critical vulnerabilities and exposures that are cropping up. We have to make sure that those are continuously remediated. So we have an engine in place that's agentic and part human driven, which is constantly remediating those vulnerabilities that surface.
Awesome. I have just in the past couple minutes assimilated the understanding of what your operating system is in whole. Let me do a little bit of a recap. I come from the engineering perspective. I'm building a product. And so I'm thinking, well, how do we make our teams better at producing the feature that we're interested in now and not stepping on his toes with merge conflicts and stuff? And that's kind of where I'm stuck. The problem that you're solving, I'm sure you probably addressed that, but the problem that you're dominantly solving is the bigger problem. Like, okay, we have the entire deployment, the entire architecture. Are you making sure that when it's time to spin stuff out, you're actually using the correct architectural patterns? Is this safe? Is this going to be built on a foundation like where SOC 2 compliance is built in? And then once we know we have the right big chunks of machinery in production, then you also address the feature development stuff. It's the company, I suspect, has their ability to direct feature production kind of the way they want to. Please fill in more in a second if I'm wrong here. But if part of these features are the important things that you commonly see, like two-factor authorization. I was building this last night. This is a project I've got for my son. He's got a website now, which is terrifying. It's on a computer in my living room. So if you're building patterns that are commonly used, then we make sure that we use a reference pattern to capture the correct implementation of it. And then finally, when it's time to go into deployment, since we know that we have the right architecture, the ability to go through intelligent automation, get this stuff out of production, CI/CD, scan it for security issues. These things are a lot more tractable because it's all following best principles to begin with. So how close am I, fill in the blanks if I've got anything important wrong.
No, that's exactly right. I mean, this is really elevating software into engineering. It is really it is truly bringing engineering into software. When you engineer, it is deterministic. You can guarantee it's going to work.
Mhm.
And with AI, how do you do that? And what you just articulated is exactly that. And understanding that none of this is a straitjacket. It cannot be. The nature of software is it changes all the time. And you should be able to change it all the time. And when you have such a changing dynamic discipline, how do you ensure discipline and maintain guardrails? I think that is the trick. And I think what we've been focused on is exactly that. And just recognizing that it doesn't stop at code, it goes beyond code. So, up until code, give everybody the flexibility to do whatever they want, except now bring the entire team into the mix and put those guardrails, that governance. If you say you're a SOC 2 organization, you are continuously SOC 2 compliant. It's not intermittently SOC 2 compliant. That's not very good. And if you're compliant, you're also secure. You're not just proving to somebody because you have the evidence, but because when somebody comes and probes into your systems, they stand the test of that scrutiny. And of course, the ongoing maintenance of that, running of that in the cloud.
So we've covered a whole lot of ground today, and it's probably about time to wrap things up. The way I like to do this is have us discuss kind of some of the takeaways for today. One of the things that you discussed earlier is like how AI is solving intelligence amplification. We've also talked about, several patterns that maybe the viewers could use in their approach. What do you feel like some of the takeaways are from today that we're going to leave an audience with?
I think the most important thing that I would tell everybody is think of AI as not just an individual efficiency amplifier, but as an augmenter of your organization's intelligence. Think not just in terms of accelerating individual outputs, but enhancing organizational outcomes. And understand the need for organizational context and knowledge base. Understand the importance of teams working together with the same context, with the right workflow. And that is because AI supports software development, which is ultimately a team sport. Innovation is a team sport. And most importantly, transcending the thought that AI generates code faster. It does that too, but that's not where it ends. So it's not just for software engineers, it is for everybody that plays a part in the software lifecycle. Product managers, project managers, architects, everybody. And never ever forget the importance of running your cloud effectively and efficiently. Because if you don't do that, then everything you've done with AI has only increased your vulnerability.
Yeah, increase your volume, increase your speed, and increase the speed at which you get in trouble. Yeah. Well, give us some call out. Tell us about your product. Where can we find you?
Well, the name of the company is BOS Framework. It's bosframework.com, bosframework.com. You can find us on LinkedIn. We have 2 products and the overall solution offering together with those 2. We call them BOS Cloud, which is cloud's intelligent automation together with DevOps, and BOS Forge, which is governed AI SDLC for teams with organizational context and workflows. And the solution we offer is modernization, application development, and AI enablement for scale-ups mid-market companies.
Cool. Thank you very much. And I've had a great time talking with you and learning about aspects of software development. It's away from my comfort. I'm sure the audience will love this as well. I'll talk to you soon.
Good. Likewise.